Alright, in this video we're gonna revisit creating a function representing the unit 7, and we'll go a bit more into detail on the various options and how to improve various things in creating this function. So one of the first things to notice is in some cases when you've just created this function and you get this representation, it doesn't seem to honor the data very nicely, especially when you have quite reasonable sized projects. It can appear as if they're not really honoring the data properly. First step is then to click on the function and actually select either intermediate depending on the size, or even go to a finer resolution and observe what's happening here. You already see that it's going to create a better match to the actual data that you have. That's one of the first things to actually do and say, at a finer resolution, does it still honor it nicely or not? We only have 3 settings, so if you really want to get a good idea, you might have to change your model bounds and say, well, actually I'll just modify it to just look in this particular region here, for example here, and do it that way. So that's going to recalculate the function. So now you get a fine resolution within this area that we're really interested in, and see if it's still not honoring the data properly. And as you can see, it already seems to fit a lot better than when we took the whole area into consideration. The other thing to notice is that you sort of see these local fits to the data a little bit. It's a little bit wobbly. It's you see these little shaded areas. So depending on the type of deposit, you can have different settings. So if we go to the processing, I still have the processing of creating this function for unit 7 open. By default, it's using this exponential function. I've left all these default as they were. One of the things to consider when especially when you look at more planar structures, like these sedimentary structures, is to actually switch to regional quadratic, which tends to become a little bit more flat and even. See, it becomes a little bit smoother. You don't have those bobs or hobs and whatever you want to call them as much. But also look at things what are happening here that seems to start curving around a little bit more. I'll explain that in a minute. I'll just focus on this side a little bit. So one of the things with the rational quadratic is that you tend to have to increase the range a little bit for slightly better results, I found. So yeah, it's already a little bit better. Seems to honor the data nicely, quite nicely in most areas. And then yeah, just seems to dive off there a little bit. Let's see if we take our complete model boundary, what it looks like across the whole project area. Right. So yeah, here you see where there's little data that actually is going up. Why is that happening, you might think? Well, as we said, we're only modeling in this area with these drill holes, but we have a number of these drill holes outside of it. Especially these ones, they have completely different units, and that they don't resemble the data that we have in our model boundary here. So for the indicator points, I'm not sure if I still have them. We turn those on here, and we'll increase the size a bit so they're more obvious. You can see that here we've got a lot of outside points. So these points will influence the function here still, because we're creating those indicator points everywhere. We didn't specify that we only wanted to have them within this model boundary or anything. So these ones are trying to push back and saying, okay, well, these areas here need to be excluded. Although we still have something here. So what we can do is to actually just take this one away. So I click on it and press the delete button, and I'll add an extra step here before adding back in the classification function. So this extra step here from the surface-based modeling is to extract points inside the model boundary. What this does, it selects only the indicator points within this model boundary, so within this oriented bounding box that we have, and only treat those ones for calculating our function. So now we set up the workflow again like this. Go into this one. So we wanted to have the national quadratic, and I think I set it to 200, and hit OK. We want to have this name. Oh, sorry. And I think that was the 7 func. So we overwrite the existing one and then run it and see what happens. See, there's still a little bit going down that direction. We can improve that even further if we wanted to. But it's starting to extend more in that direction. So we can start playing with having denser sampling to make it on a bit better. We can play with the range a bit more and saying, well, actually we want to extend it a bit further, maybe up to 300. Let's have a look what that does. It'll take a little bit longer. Yeah. So now it's still starting to curve up a little bit, and that's nature of the function. When you're getting too far away from the data, it starts to curl around a little bit. But at least in this area here within our model boundary, we don't really see this increase in the function going up. So it's just away from where we have any data. Yeah, so now we have played with that a little bit. We've got service quite nicely honoring the boundaries between the units, and we don't have any humps. So I'd say this is an improvement over what we've done before. I'll leave this for now as it is. So if we go back to the classification, we could also try the other option, like a Gaussian. And in our experience, the Gaussian is actually best suited for more intrusive type domains. So if you look what happens here, the Gaussian really has this inherent urge, I would almost say, to actually curve back on itself. So away from the data, where there's no data, it starts to curve around quite a bit. So that works really well if you have some intrusive units that are really encapsulated by other units. For more almost flat type units, I wouldn't recommend it. Yeah, you go for either the exponential or the rational, quadratic, rational quadratic here, or the exponential. So in addition to this setting on what type of classification function you want to use, I also want to draw the attention of the importance of the actual sampling settings. So by default it's probably about 5 meters, but if I sample within the unit that we want to model at a higher sampling compared to outside of it, let's set the inside as being 1 meter and everything outside as 5 meters. We'll go back to F3D and run it here. Hope it will be quite visible. Yes. So what you see, it doesn't honor the data as well anymore, and that's inherent in the system because it's a classification that takes noise into consideration a little bit. So if you have very dense points that you're generating by resampling you drill holes to say, we create indicator points for the inside unit, which is this unit 7 in this case, and very low sampling below, it starts to add a lot of weight to those points on the inside, because you got so much more of those that the system will think that these are the more important ones, and it starts to push the boundaries a little bit downwards. So if we change that around, for example, and say, well, actually we'll take that on as 5 meters and turn that around, we should see the opposite effect. It's just running now. It's going to take too long. Maybe a little bit longer than the other one. So now you see that this boundary between the units is now shifted upwards. So actually the units appear more below, because we now created many more points below this. So the outside of the unit that we want to model, which is starting to push this boundary upwards. So generally, in most cases, you want to set them more or less equally spaced, so in either 5 meter on either side. But depending on the situation, if you have very thin units and very thin sections here, for example, you might want to increase the sampling inside the unit compared to outside of the unit, and play with that a little bit. So if you see that it's not really honoring the data properly, it's an important thing to look at. So now I've set it back to 5 meters and on both sides, which in this case does a reasonable job. Most areas, even here. But you have to be aware of that a little bit, that the sampling itself will actually determine how closely the function will actually match the data.